In this fourth and final video from section 6.1, we'll talk about really two things: the density of rational numbers and also approximations and roundings. So the density, what do we mean by that? We've seen that term, that word before when we were talking about fractions and how fractions, between any two fractions, you can find another fraction, right? We did that in a previous chapter. We looked at them on a number line, and we looked at how you could get common denominators and then increase the size of those denominators to find another fraction between any two fractions. You can do the same thing with decimal numbers as well. And so I'm just going to throw out the question to start. If I give you these two decimals, can you give another decimal? Can you find another decimal that exists between those two? And so so to start, I want you to sketch a number line because we're again focusing on the visualization of these things and the modeling of these things. So sketch a number line and see if you can find a decimal number that exists between those two. So one way to do this, if I draw a number line and I say you are there and you are there, we could cut this up into 10 equal pieces between them. Might look something like that if those are equal. Before we go further, I just want to ask, each one of these segments that I just drew, what are those representing? What place value? It's going to be one more than what we currently are going to. So this is the tenths, hundredths, thousandths. So these would be the 10,000ths place. We're really zoomed in here. One way you can do this, and I mentioned this in a previous video, is to really express both of the decimals that we're working with one digit further, one decimal place further than it was already stated. 1,240 10,000ths, 1,250 10,000ths. We just needed to find a number really between 40 and 50. Let's go, my favorite number, 47. 0.1247. Notice how it has the 124, 124, and then one additional number after it. We could have chosen any of these that are between 0.124 and 0.125, but that's one way to do it. Let's look at another pair, and we're going to find a number between 0.47 and 0.621. So with these, they have different number of decimal places in them. We can still do it. So what we might do here is, to help us with this process, is to extend the 0.47 with a 0 so that now they have the same number. So can we find any number really between those two? It could be all sorts of numbers. Because the tenths places are actually different, 4 and 6, we could just go with the tenths place that's between 4 and 6, which would be 0.5. Or, to help us even see this a little bit better, since these were both written to the thousandths, 0, right, 470, 621, those go to the thousandth place, we could put 0.500, 500 thousandths. So again, a couple different ways to see that. So in this one, we started with numbers that had a different number of place values. What if we do one more and say 1.1 and 1.2? We find a number between them, sketch a number line, find a decimal number that exists between 0.11 or 1.1 and 1.2. So again, if we add a 0 to the end of both of them, now it's 1 and 10 hundredths, 1 and 20 hundredths. Doing a bad job of spacing these out evenly. That's better. So let's just go right in the middle. what would that be? What would be the value of that location? 1 and 10 hundredths, 1 and 20 hundredths. Well, what's between 10 and 20? 1 and 15 hundredths. So 1.1, 1.2, 1.15 is right in the middle of those two. So the density of decimals really talks about how there's always another decimal between any two numbers, right? And we kind of saw that earlier, right? Between these two, you can separate those into 10 spaces and zoom in there. And between each one of those spaces, you can break that into 10 more spaces. You could just keep doing that really forever. So the last thing I want to talk about is approximations with decimals, doing a little bit of rounding. And for this exercise, I want to start by talking about calculators, actually, because we use calculators a lot. And what I'd like you to do is see if you can grab some different calculators that might be around your space. Maybe your phone, maybe on the computer, maybe just some handheld calculators, because I want you to try something. So go ahead and pause and see if you can track down a couple calculators. I have two calculators pulled up on my computer that I just found online. And what I want you to do is I want you to take and divide 2 by 3. So we're going to do 2 divided by 3. And so this calculator, when I do 2 divided by 3, notice what shows up in the display. 0.666666667. Hey, there's one of those repeating decimals, right? And then I'm going to go to, if I just type in calculator to Google, it just pops up a calculator. I'm going to do the same thing. 2 divided by 3. 2 divided by 3. And look at what it gives me. This. What do you notice that's different between these two calculators that I used? It's the same fraction or the same division problem. And I know that it's going to be this repeating set of sixes, but one of them has a 7 in the last digit and one of them does not. So this is an interesting thing about calculators. Some of them are programmed to round the last digit, and some of them are programmed to just cut numbers off at the last digit. And I find that interesting because it could lead you to thinking that one answer is different from what it actually is. And so you have to know how your calculator behaves. So let's talk a little bit about rounding then. Decimals can be rounded in a number of different ways. We can say we want to round by and then state some place value. We can say round to the nearest whole number, round to the nearest tenth, round to the nearest hundredth. Or we can say by number of decimal places. These are the two most common ways to state a rounding situation. Round to 1 decimal place, round to 2 decimal places, round to 3 decimal places. You can phrase it a couple different ways, but I also want to look at what it actually means. So I'm going to give you a decimal number, and we're going to start with 0.648. And we're going to round to the nearest tenth. Round to the nearest tenth. And first of all, we're going to identify the number that's in the tenths place. And it's this 6. So what that means is when we write our final answer, it will only be stated to the tenths place. There will be no other numbers after the tenths place. It'll only have a number in the tenths place, and then it will cease to have any numbers. When we round, we're really saying, what's it closer to? Here is what your manipulative piece, your decimal score, would look like for 0.648, or as you would say it properly, 648 thousandths. So we'd be using the thousandths place. So again, we have 1, 2, 3, 4, 5, 6 full columns filled in. Those are for the 6/10ths that we have right there. And then you'll notice we have 1, 2, 3, 4 of the hundredths blocks filled in. And then you see that we've got a few of these thousandths sections filled in, 8 of them, 8 of these thousandths sections filled in. So we are rounding to the nearest 10th, which means we are looking at this picture in terms of these full columns, right? It's saying it's really hard to do this on this little machine here, right? If this is a full column, how many of them could I fill in? And where would this last one be closer to? Is it closer to filling in the column? Let me take my time with this. Are we closer to filling in the column? Or are we closer to taking these away? And we didn't get quite halfway to filling in that column, which means when we round it, we're going to round down. We're going to be taking these and eliminating them and only looking at, let me try that again, eliminating them and only then looking at these first full 6 columns, which we could then state as 0.6 or 6/10ths. A common way that people will do this also is once you've identified the place where you're going to round, you look at the next digit, and that helps tell you whether or not you're more than halfway there. If it's less than 5, you round down and eliminate these. If it's 5 or greater, you would round that number up, right? We would have filled in this column to make it a 7, but we weren't halfway there. So let's look at another one. Let's look at 0.863. 0.863. And we're going to round this again to the nearest 10th. So let's look at what the picture looks like again. Here is a decimal square with thousandths. So notice how this one's a little bit different. We here have 8 full columns, 8/10ths. Again, each column represents a 10th of the entire square. And then we have 1, 2, 3, 4, 5, 6. So we have 6 hundredths. Each of those blocks is 1/100th. Okay. And then we have these 3 thousandths. Okay, so we have 8/10ths, 6/100ths, and 3 thousandths. What we were asked to do is round to the nearest 10th. So again, that's basically determining this column, do we count it or not? Are we going to keep it at 8/10ths? Or are we going to fill in the rest of this column to make it 9/10ths? And the question is really, are we more than halfway there? This line would be the halfway point. And you can see because we've filled in above it, we would fill in the rest of this column when we do our rounding, which means this is going to round to 0.9 Another way to do it is look at that next digit, the 6. Because it's greater than or equal to 5, this 8 gets rounded up. That should be, it makes it an arrow sometimes. I apologize for that. There's an autocorrect feature happening there. 0.9 tenths. Now, one question that people sometimes have is, what do I do with the number like 0.35? Do I round that up or I round that down if I'm rounding it to the nearest 10th? Because if we say nearest, the nearest tenth, this is sitting at halfway. So we're asking again, do we count this column or not? We could go down or we could go up, and it's the same distance either way. The rule of thumb, and the one that this book, our textbook, adopts, is that we round up, right? So we would round this up to 0.4 or 4/10. And I think that's pretty standard in most situations, okay? Where a 5 or greater in that next place value leads to us rounding up. Now, the two numbers that we had looked at before, I'd also like to round them to the nearest hundredth. So before we rounded to the nearest tenth, so now we're going to take 0.648 and 0.863, and we're going to round these to the nearest hundredth. So take a moment and try that. Here's what the picture looked like for 0.648. And here's what the picture looked like for 0.863. Let me enlarge them slightly for you. So when we are rounding to the nearest hundredth, we're not looking at the columns anymore. We're looking at the individual blocks. We're looking at this last block here, and we're saying, are we going to count that block or not? We know we have 6/10 from these 6 columns. And we know we have 4/10 from 1, or 4/100, sorry, from 1, 2, 3, and 4. We're just asking, are we going to count this 5th block or not? Well, you can see that it's more than halfway filled in. The entire bottom is filled in, plus those right there, 8 of them. 8 of the 10 thousandths sections are filled in. So we are going to count this block, which means we are going to round it up to 0.65. We're going to count this block and not consider any more of the thousandths. 8 rounds that 4 up to a 5, and we have 65 hundredths. What about this one? 0.863. Again, we're rounding to the nearest hundredth, which is this place right there. So when we look at our diagram, again, these first 8 tenths are all taken care of here. So are these 6 hundredths. We know that those are included. We're just asking the question, are we going to include that block or not? Only 3 of the 10 sections are filled in. It is not halfway there. So we're not going to count that last block. We're not going to count that last hundredth. So we're going to round down and leave it at 0.86, 86 hundredths. So maybe rounding is something that you've always been able to do, or maybe not. Maybe you've struggled with it. My hope is that these visuals are going to help you see what's really happening behind the scenes when you are doing those roundings. So let's kind of end this with just a couple more for you to do on your own. I'm going to give you 0.283, 0.068, and 14.649. And we are going to round them 2 different ways. First way, we're going to round to 1 decimal place. Notice I'm using a different language there, 1 decimal place. And secondly, we're going to round to 2 decimal places. So we're going to do that for both of them. So take a moment to try to do those on your own. So rounding to 1 decimal place is the same thing as rounding to the nearest 10th. Rounding to 2 decimal places is doing the same thing as rounding to the nearest hundredth. Those mean the same thing. So we're going to use the strategy, since I don't have diagrams, the rules for rounding decimals. I talked you through them earlier, But what they really come down to is this. If you'd like to, if you prefer to write some rules down, write some definitions, right? So we locate the place value to which the number is to be rounded and check the digits to its right. If it's 5 or greater, all the digits to the right are dropped, and the digit with the given place value is increased by 1. We say that is rounding up. If that digit is 4 or less, then we just drop all the digits to the right. So 1 decimal place is the 2. I look to the digit to the right. It is 5 or greater. So I'm going to drop all those digits, and I'm going to add 1 to the 2 and make it a 3. 0.283 is close to 0.3. Now, if I wanted to round it to 2 decimal places, I would have looked at the 8, and then I would have used the 3 next to it to determine that I would round down. I would leave the 2 in the 8, and then I would just eliminate the 3. So 283 thousandths either rounds to 3/10 or 28 hundredths, depending on where you're rounding. For the next one, 0.068, this would round to 0.1 or 0.07. Here's 1 decimal place. The 6 is going to round the 1 or the 0 up to a 1. If we're rounding to 2 decimal places, the 8 is going to round the 6 up to a 7. For this final one, we will have 14.5. The 9 will round the 4 up to a 5. And for the next one, we're just leaving it at 14.49 for 2 decimal places because that's what it already is. And so this whole section, again, was laying fundamental, a foundation for all the things that we're going to be doing as we move forward working with decimals.